Hi everyone, so now I will explain a bit about the solution for the tutorial related to the triple integral by using the Cartesian coordinate. So it is page 80, exercise 2e, and this is the question 2b. So by using the triple integral, you have to find the volume of the solid which is bounded by b. Okay, so b, you have a plane. Okay, by the plane y plus z equals to 1, y equals to x squared, xy plane and also yz plane. So first of all, we need to draw out the solid. Okay, and the solid is actually covered by all these planes. So we draw each of the plane one by one first. So the first one, okay, if you look at the equations, okay, it is a straight line equations. So this is a z-axis and this is a y-axis. If you move your y, okay, to the left hand side, to the right hand side, you will get your equation z equals to 1 minus y. Okay, and this is the equation for a straight line. Okay, so the intersection point will be 1 and the intersection point at axis y will be 1. So it is a straight line, you join it. Okay, and for the second plane, it is y equals to x squared. This is a quadratic equations. Okay, quadratic equations. So this is the equations. Okay, this is the curve. So you have to make sure you know how to draw quadratic, how to draw straight line. Okay, and I believe that you learned this thing before. Okay, so you have to refresh back. Okay, this is the quadratic equations. XY plane. Okay, so what is XY plane? Okay, XY plane is a plane that exists parallel to the XY axis. Okay, it is at the bottom. You just imagine you have a you have an infinite size of the plane. Okay, located, okay, at z equals to 0, horizontal plane. Okay, it is somewhere here. Okay, so it covered this part. It covered this part. And the YZ plane. Okay, this is your YZ plane. You just imagine you have a vertical slab. Okay, cover this YZ plane. You can refer to your module. Okay, I think in chapter chapter 2, I think. Okay, is page 9 of your module. Okay, page 9 of your module. Page 9 of your module. Okay, it explains about what is XY plane, what is YZ plane, and also the SZ plane. You can have a look at page 9 of your module. Okay, so fine. Okay, so now we have to extend these two. Okay, this first of all we draw these two lines in 2D. Now we have, because they are planes, so we have to extend it in 3D. So we draw this one first. Okay, so in this is the y-axis, x-axis, and this is your curve here. Okay, this is your curve here, and we extend it in z direction. Okay, so it means that no matter what is the value of the z, you will have the same quadratic equation. So when I combine all of it, okay, you will see this shape. Okay, this is a shape. Okay, I hope you can check this one. This is a shape. And how about this one? This is the zy plane. So I draw a straight line zy. Okay, zy here. Again, zy. Okay, and this straight line will extend in the x direction. So you get this. Okay, you get this rectangular plane. Okay, so you have to imagine. So when you draw the 3D, you need a lot of imaginations. Okay, so you have to imagine now you chop, okay, or you slice. Okay, you slice this shape, this quadratic solid, you slice it. Okay, by using this plane. Okay, and the XY plane actually cover the bottom part, and the ZY plane actually cover the center part. Okay, so this one will be the solid that you need to find is volume. Okay, so you need to choose a projection. Okay, so in this case I choose the XY projections. It means that you look at the solid from top. Okay, from top. Okay, when you look at the solid from top, okay, you will find this shape. Okay, here, this shape. Okay, I stopped and didn't consider the shape behind, because you have a YZ plane to cut this thing, so I only consider these portions. Okay, I consider these portions. Okay, that's why I'll draw it out. Okay, this is the X here, X here. Okay, when you extend it, the value is 1, and this is the Y is 1. I stop here. Okay, because you slice by using the this plane. Okay, you slice by using this Y plus Z equals to 1 plane. Okay, that's why I stop here. Okay, so this is your XY projection for you to define the interval of your dx and also the dy. Okay, so you have to apply either vertical strip technique or horizontal strip technique. In this case, I choose the vertical strip technique. Okay, when you move this vertical line to the left, okay, you will stop here. Okay, where the value is 0. And on the other hand, when you move this vertical line to the right, you will stop here, and the value is equals to 1. Okay, so this is the interval for the dx. As for your dy, you have to imagine yourself sitting inside this strip, and when you refer down, okay, you see this curve, and the equation of the curve is y equals to x squared. So I will start from the x squared, and when I move up, I see a horizontal line, and this horizontal line has the y value equals to 1. Okay, so this one will be the interval for my x and y. Next, in order to define the interval for my z, I have to imagine myself sitting inside the solid, and when I look down, okay, I will look down, I will see a flat surface, okay, which is z is represented by z equals to 0. Okay, so my z interval will start from 0, and when I refer up, I will observe a surface which is cut by this plane, right? Okay, so the upper surface is cut by this rectangular plane. That's why I will stop here. Okay, z equals to 1 minus y. Okay, I have to move my z to the right side, z at the right side, and I move my y to the left side in order to represent the interval for my z. Okay, so after you confirm this interval, you insert them into the triple integrals. Okay, you need to find the volume. So this one is 1, z, okay, this is the interval for z, y, this is the interval for y, and the last one is dz, the interval. And you have to remember, value will always stay outside. Okay, you don't put the value inside or variable outside. Okay, you have to remember those interval that has a value, okay, you have to put it outside. Okay, then only you can get the value for your answer. Okay, so you solve like usual, perform integration first level, after that second layer, and lastly is the third one, the last one. Okay, so for this one, you can press calculator straight away. You can press calculator straight away. Okay, please make sure you find out how to use your calculator and to press the to find the answer for integration, because it saves your time. Okay, you also ensure that you get the correct answer. So the answer is 4/15 units cube. Okay, represent the volume. Okay, next let's look at 2C. So 2C is very similar, okay, as the B, but without the YZ plane. Okay, basically this one is the same, this one is also the same, but here is replaced by z equals to 0. Actually, z equals to 0 is equivalent to the xy plane, right, at the bottom part. So just now we only consider this section, right, because it is cut by the yz plane. But for this question, okay, it doesn't contain the yz plane. It means that we no need to cut. We have to consider the whole solid. So we have to consider the whole solid here. That's why when I do for my xy projection, I have to consider the whole thing here. Okay, I have to consider the whole thing here. Again, I repeat, I stop here because I slice it. Okay, I cut the solid by using this rectangular plane. That's why I stop here. Otherwise, this one can extend to infinity actually. Okay, so this one will be my xy projections. Okay, first thing is to define the xy interval. Okay, when you are in the xy projections. So when you move the vertical line to the left for most, you will stop at -1. And when you move this line to the right most, you will stop at 1. Okay, so the interval for your x will be -1 to 1. And for the y, okay, refer down, you see this curve, right? So it is x squared. Okay, and when you refer up, you see a horizontal line where is y is equivalent to 1. Okay, as for the z, okay, same thing. Okay, when you refer down, okay, you see a flat surface at the position z equals to 0. And when you refer up, you see a surface which is cut, okay, by this rectangular plane. And the equation of the rectangular plane is this. So you have to move your y to the right, so you get this one. Okay, and now you plug in all the interval into the equation and solve it like usual. Okay, you can refer the steps. And finally you get this one. Okay, this is 8/15. Just now our answer is 4/15, so it is double of it, right? Just now we only consider one part, now we need to consider the second part, so it is double of it. Okay, next we move on to the question D. Okay, so this solid is bounded by the surface y equals to x squared. Okay, you have drawn this thing before. Z equals to 0. Okay, this is equivalent to the xy plane. And z equals to 4, y equals to 9. Okay, so this thing is very similar to the previous two questions. Okay, you have this one. Okay, this one is your y equals to x squared, and you extend it in the z direction. Okay, the difference here is this question is specific. Okay, z equals to 0, which is this one at the bottom, z equals to 0, and it stopped at z equals to 4. Okay, it stopped here. Okay, it stopped here. And y equals to 9. So imagine y equals to 9 is this one. Okay, this plane, y equals to 9. Okay, just now I mentioned that this line actually can extend to infinity, but the question asks you to stop at y equals to 9. That's why you have this plane. Okay, this plane is actually the y equals to 9. Okay, same thing, I will do the xy projections. This is your xy projection. So when your y stop at 9, this one will be -3. Okay, you can replace the 9 here. Okay, so when you have -3 or +3, you square it, you will get 9. Okay, so it depends on the value, okay, stated here. So when you do the vertical strip technique, your x will be from -3 to 3, and your y interval, okay, will be from x squared. Okay, you will see the x squared, and when you move up, you see a horizontal line where its value is 9. So here, And last one is the Z interval. Okay, Z interval means you have to imagine yourself sitting inside this solid, and when you look down, okay, you see your Z equals to 0, okay? At the position Z equals to 0 is a flat surface, and when you refer up, you see another flat surface, which is Z is equals to 4. Okay, that's why you put this one as your interval Z. Okay, lastly, you plug in the interval and perform the integration one by one. Make sure all these things you plug in correctly. Okay, don't simply put, okay, not according to the z, dy, dx, you will get wrong answer. This one should match with this one match the other one, and lastly is this one. You have to make sure that they are matching. So you will get 144 unit cube for your answer. Okay, so this is the exercise for the triple integral. If you have any questions, okay, please let me know. Thank you.